So you may be someone who loves mathematics but hates dealing with all those numbers. Don't worry, you can do math without numbers. And here's why you can do that and why you shouldn't do it. But it depends on what you're into. So in digital or discrete mathematics, you have things like 3 times 6 equals 18. That's what we all learn in school. In analog mathematics, it's different. So you have, this is the unit, this is the length of 3, this is the length of 6, and you multiply them by drawing a triangle or an angle, and you use parallel lines. So these are our parallel lines, and then this means that as 1 is to 3, 6 is to, this turns out as being 18. So this length is 18 units. So you don't have to do numbers, you can also just do the line. So we have like 1, this is a 3, this is 6, and this is it's not working too. So as you can see, there are problems here. Because if you did 18, it would go up much further, up to like here or something. And so that's one of the problems with analog mathematics is when you want to have very big numbers, you have very long lines, and that's not great. But you can do it. I'll show you a few more examples of analog mathematics. Another one is pi. They say you can't measure pi. You can in analog mathematics. In analog mathematics, what you do is you have a circle, you have a diameter, make a little wheel thing, and you run the wheel around the big circle. And so you make a mark here when you start, you make a mark here when you end, you count how many rolls you add in between. So let's say this takes 10 rolls plus this arc. 10 plus arc. That is 10. If I wanted to go completely analog, I could do something like a ratio, like that ratio. It works. Anyhow, I can also roll that wheel out and produce a length like here and a length like this. And behold, this is pi. Exactly. The problem is, if you use the wheel, you'll actually get an accurate answer, but it's not going to be, I mean, how do you know it's accurate? How do you measure it? And what if your wheel slips? And all sorts of other things, like what if the board's not flat? That's one of the problems in analog mathematics, but you could do it does work mentally. Likewise, let's do some calculus here. We want to find the integral here. Well, one thing you can do in analog mathematics is you can divide it into columns, estimate it. We don't need to estimate this. In analog mathematics, you don't need to estimate. You just do things. So you could even do something like, I mean, if you had these and you had like little walls, and this also had like walls attached, you could just like take a line here, and what you do is you just fill this area with water, for example, and then take this length here. So you fill this with water, and then you have like a cylinder, and you dump the water into the cylinder, and we just say that this is the height of fluid of a unit, and then we fill it in, and the fluid ends up being like here. And so then we say the integral is equal to this ratio. That's the integral. Analog mathematics. Integral is very simple. So as you can see, there's some problems here. Pouring water. You have to make a unique solution for every different problem. There's not like general rules, but it works. It's simple. You don't have to do heavy math.